So now that we have studied reciprocal functions, we are going to, and reciprocal functions always came in a pair, we are going to move to rational functions. And rational functions don't come in pairs, they are standalone functions, and they are formed of the ratio of two polynomial functions, so the fraction of two polynomial functions. So your numerator and your denominator are both polynomials, and this creates a rational function. We will use four properties to graph the rational functions. So from the equation, we can identify the x-intercepts, the y-intercept, the vertical asymptotes, and the end behavior and horizontal asymptote. So the x-intercept comes from when your function equals 0. So when does 5 over x plus 4 equal 0? This will be never. There will be no x-intercept because what happens is 5 over x plus 4 equals 0, and you will multiply your denominator by 0, so 5 is 0. This is untrue. There are no x-intercepts. So to find the x-intercepts, you will look when your numerator equals 0. Your y-intercept is just by plugging in 0 for x. So f at 0 will be 5 over 4. There's our y-intercept. The VAs come from when your denominator is equal to 0. So x plus 4 is 0 when x is minus 4, and that's your vertical asymptote. The end behaviors come from the quotient when you divide the numerator by the denominator. So what happens if we try to divide 5 by x? We can't. So this means that our horizontal asymptote is at y equals 0. So our end behaviors is x approaching plus or minus infinity, y is approaching 0. So let's put those four features on our graph. Usually I start with the VA at minus 4 using a ruler, and the HA at 0. Then I will put my 2 points, which no x-intercept and a y-intercept at 5 over 4. And then we'll connect the key points and approach asymptote. So actually we only have one key point, but to go through this point and approach the asymptotes, you know what shape we get. On the left side of the asymptote, we have no key points. So let's see what is happening at negative 5. We'll have 5 over negative 5 plus 4, so negative 1. So we actually get a point at negative 5, negative 5. And so we know we need to respect the vertical asymptote, and we'll be heading towards 0, but just we're a little far away from that now. So that is how we do the sketch of a reciprocal function. So for the second one, to find the x-intercepts, consider when the numerator equals 0. So x at negative 2/3. For the y-intercept, plug in 0. So we'll have 2 over negative 1 or negative 2. For the vertical asymptotes, when does the denominator equal 0? When x is a quarter. And for the end behaviors, what happens when we divide 3x by 4x? We will end up with 3/4. So we have a horizontal asymptote at y equals 3/4. You with your rulers are going to have a much better time than me, but I will draw a vertical asymptote very close to my x-axis and a horizontal asymptote very close to y equals 1. All right, and then there are 2 points to put on. An x-intercept of negative 2/3 and a y-intercept of negative 2. meaning we can go approach our ends through these 2 points and not touching or crossing our vertical asymptote. Over here on the right, we don't have any points, but we cannot draw it below because then we would cross the x-axis and there are no more x-intercepts. So the other shape will be over here. All right, what happens when we get now a quadratic over a quadratic? I think for ease, can we factor this? Our numerator, denominator is a difference of squares. And in our numerator, we'll have a 3x. If we multiply that by 2 and subtract 1x, we will get the 5x in the middle and a negative 2 at the end. So when does our numerator equal 0? So when x is negative 2 and x is a third. Note that that negative sign isn't impacting the numerator. And the x-intercept, the y-intercept will be negative, and then those cancel out, so I'll have a negative 2, and the x will cancel out over negative 9. So overall, I have a negative number. Negative 2 over 9 is the x-intercept. No, the y-intercept. The VAs come from when your denominator is 0, so at plus and minus 3. And the HA comes when we divide a negative 3x squared by an x squared, we will get negative 3. So our ends are approaching negative 3, or we have a HA at y equals negative 3. Let's put the two VAs at negative 3 and positive 3. And a HA at negative 3. All right, some points we can put on. X-intercept of a third, a y-intercept of negative 2 over 9. Okay, so what we have here is to be able to, what do we have here? I need to pause for a second. Okay, good, because what I forgot was my second x-intercept at negative 2. So I have 2 x-intercepts, 1 y-intercept. So now that will help me. I have to stay within my asymptotes. I will come down through these points and back up. On the left and the right, there are no more x-intercepts, so I'm going to have to draw below the horizontal asymptote, and my ends are approaching negative 3, but I'm respecting the vertical asymptote by not touching or crossing it. So our final example, let's factor our denominator, x plus 5, x minus 5. So our x-intercept comes from when our numerator equals 0, so at negative 1. Our y-intercept will be subbing in for 0, so 1 over negative 25. Our VAs are when our denominator equals 0, so at negative 1 and 5. And our end behaviors are approaching the quotient of when x is divided by x squared. But x can't be divided by x squared, so we're going to be approaching 0 with a horizontal asymptote at 0. So putting on our VAs at negative 1 and 5, our HA at 0, our points, an x-intercept at negative 1, and a y-intercept at negative 1 over 25. Okay, not that much we can do there. But how is this going to look? So I need to, do I need to analyze this a little bit? Yeah, what mistake have I made? Oh, my messy writing. That was x plus 5 and x minus 5. Okay, so that's where our vertical, because I was like, we can't have a point on our asymptote. What is going on? So this is at plus or minus 5. Okay, so don't have messy handwriting. So here, okay, so now I've got the correct asymptotes, the horizontal asymptote, my point at -1, and my x-intercept and my y-intercept. Okay, so what we have to do is we can only cross the axis once and go through that point, so we're going to have to come through and pass through there and then respect the asymptote. Okay, on the left, I don't know if I'm above or below the asymptote, so let's test f at -6. So I'll have -5 over 36 minus 25, so -5 over 9. So I'm below the x-axis, oops, like that. And to the right, if I test f at 6, I'll get 7 over 36 minus 25, 7 over 9. So I'm going to be positive, and that's how I finish off the graph. Okay, so definitely it causes some thinking and a few bumpy moments there. I'm sure if you work in pencil, you'll have bumpy moments too, but you'll be able to realize when things aren't making sense and make adjustments as needed. So have fun practicing these graphs.